to another coding session with Bangalang, our language that we are creating, and we're making good progress, working through our to-do list. The features is still a pretty big list. I keep adding things to the bottom. But what I want to tackle today, and I feel like it's going to be quite a big one actually, is default parameters. I feel like it's going to be a bit of a challenge to get this in 1 hour, but let's see what we can do. Hopefully our work last session enforcing colons on declarations is a bit of a help. Let's see. But before we start with that, I just want to squash this. At the end of the last session, I noticed that if I try to convert a negative number to a string, I get a big fat number. And I was like, why is that happening? And I did a bit of some files from my playing around, and I did a bit of investigation, and I tracked it down. I think it was the generation of an expression when we're doing integers. Yeah, we have all this logic here to say whether we use L or B or G or A for less and greater, because they and this is when we're doing our comparisons, less, greater, because it uses different notation depending on whether it's signed or unsigned. But the way that I decided whether it was a signed integer type was to use the result type node. And what I didn't think about was that if we're doing a comparison, the result is actually a Boolean. So this value would be bool, which is not a signed integer. So this would always be false, and it's treating everything as unsigned. So what I actually wanted with this was this, which actually makes me think, I think there was one other place where I did this, right? Generic expression integer. What is this? Oh, this is where we decide whether it's an integer. So here we had this here with operand type. Probably should have just copied that. With assignment, we use the left-hand side type node, which is an operand type node. And here we just use type node. We only get type node. Okay. So I think that solves that part. See, now it's showing it's a negative number, but it puts the negative sign at the end, which is also not right. And I can't remember if I mentioned this last time. One other thing I noticed was, let's just leave it I64 for now. It's because right at the start, we check whether it's negative, and then we add the minus sign to the buffer, but at the end, we reverse the buffer. And so this ends up at the end. So I think what we actually need to do is just create a negative flag. And if negative, we still want to just negate. And then this is where we fill the buffer, right, with the digits. So then after that is where we want to put our negative sign. So we put it on the end. And so here, all we want to do is just, if it's negative, then we change it to a positive value so that we can so that this loop works nicely. Okay, so hopefully that fixes that. There we go. All right, so those are nice. I can get rid of this testing code. And let's get stuck into our default parameters. So I think we need to make a bit of a grammar change here. Basically, I want something that we can put in our procedure type here, which is using this left-hand side declaration. I don't want to put just assignment in there because it's too open. I want something a bit more restrictive. So I'm going to make something here called a declaration, which has a left-hand side declaration, and then optionally it has equals. Optionally it has equals statement. I think that's right. Yeah, that looks right. So this is the simplified version that is just a declaration. This assignment could be a declaration or an assignment to an existing variable. And this is what I want to put down in here. So we take declaration, and in the procedure type we put it here and here. I think that's right. Yeah, so procedure type is proc, opening bracket. Optionally we can add some declarations, which are a declaration followed by 0 or more comma declarations. Okay, that looks right. So now we just need to make a procedure that parses a declaration and use it in the procedure type. So I guess we'll just take this assignment one and simplify it. Does that sound right? I'm still going to just call it an assignment node because that's what it is. It's just a more restrictive assignment. So the left-hand side is just a left-hand side declaration. I guess we keep this stuff. I think I need to rework this return business. Here we're just going to say, I think I'm going to actually put this here, and I'm just going to say if peaktoken.type is equals, because that's the only operator we can use. Does that mean we don't need slice? I think we don't need slice. So that's dot equals, and I think the rest is the same. No changes there. It's just optional based on whether we have an equal sign or not. So that was pretty easy. That's a declaration. So then we wanted to use that in our procedure type. So this is for each parameter in the procedure. We do all this. So the first thing is this allows trailing commas, which are not allowed in the grammar. The grammar doesn't allow them. I'm a bit undecided whether we should allow them. I don't personally like to use them. So just for now, because the grammar says we shouldn't have them, I'm going to say that they're not allowed. We can always change it later. So I think the way we do that is we say if so this is saying if we've already added a parameter, then next time we loop around, we need to do a comma first. That's how it works. And this whole thing here was to create the parameter, but now it's just parse declaration like that. Which I guess needs a context. But we don't have a context in here. What does it need the context for? Yeah, it's this. I really do want to get rid of this. I don't like it. Parse procedure type. If we have to pass a context in there, is it the end of the world? Currently a primary doesn't take it. Son of a gun. Okay. I'm just going to do something like this for now. It might be a bad idea, but I want to review this anyway. And really this should only be scoped to within here. This thing, like once we leave here, we don't know that the return value is still required. We're in a different procedure. Yeah, it's not nice. We'll fix it later. But that gets our declaration working anyway. And then we don't need that. Right? Is that what I decided? I thought that's what I decided. Okay. Okay. I don't think there's anything else we need to change. It's just these parameters that were changed. Cool. So that's the procedure type. That's all the parsing, I think, changes that we need. And we should have the correct information. This does change the structure now. Previously, procedures were just identifier nodes that had type information. Now they're actually assignment nodes. So yeah, it's a different structure. So we're gonna have to take care of that. I think anywhere we see params type node, that's kind of somewhere we need to take care of. That's generation. Parsing we already did, so I'm just looking for type checking stuff. This type checking assignment, call, and type checking of types. Okay, so this is an assignment. So this is where we set up the parameters of the procedure. We add them to identifiers. And the extra check that I want to put it in here is, because with defaults, the one place I can think of that we can put defaults, I'll put them in so it becomes a bit easier. So this is call. Quite often, like it's a very generic thing to call. So sometimes you need to use all the parameters, sometimes you need to use hardly any. See, like here we have all these trailing zeros to the syscall. Cut them off, cut these off, cut these off, and cut these off, because we have defaults of 0 everywhere. So what we should not be allowed to do is this, because then if you only supplied these two, for example, then it defaults this, and then what's this? You know, it doesn't really work. And generally languages don't allow this. So I wanted to put a check in here where we loop through. Oh, and the other thing, of course, the reason I was searching for this is because this is now an assignment node. So we need to do something like this. We need to get the left-hand side. I think that needs to be like that. Why is this E orange? Something's going wrong there. So this is the assignment node. So this here is the identifier node, which is what we had directly before. So we're making sure that everything that's a parameter is a stack variable, stack allocator, and adding it to the identifiers. And what I also want to do while we're at it is, that's right, make sure that all the defaults are at the end. So if I go like found default, and then I guess I just need to check like if the length of the children is greater than 1, that means it has a default, because that means it has a left-hand side and a right-hand side, i.e. a default, you know. there's the left-hand side and the right-hand side of this assignment. So if there is, so that's one child, two, three, there's three children. So if there's more than one, so this one only has one. If there's more than one, it must have a default. So that means found default equals true. And I guess before that, we need to say if there is only one, and we've found the default, then we have an error, right? If there's no default, but we have found a default previously, that means we've got something with no default after something with a default. So procedure parameters with defaults cannot be followed by parameters without defaults. That's the error has no parameters, just like that. So that should make sure that we can't do this. Can't have default, no default, default. Hopefully. Oh, this is, all of this code is assuming that you have, so this is the outer assignment because this statement here is also an assignment. In this particular case, it only has a left-hand side. We're not saying syscall equals some stuff. So I only got a left-hand side. And here we're saying if there's more than one, i.e. if there is a right-hand side, then go in here. And now we're doing this check. So that's not going to work actually for this case. So I guess we need to move this out. And this stuff also, does it hurt to move that out? I don't know, let's try moving the whole thing out. But I think we need to make sure that it is, we're talking about a procedure still. We're talking about a procedure, but it doesn't have to have a right-hand side. We're only concerned with left-hand side here. Left-hand side type node. The hell? Where did my left-hand side type node go? I just wanted to check where else that's used. Only in here. I'm thinking that it will be okay. We'll do it after this because this could add type information. So we'll put that there. Okay, we have some errors down here. Because we reset it. Okay, I just want to keep this simple and I don't want to mess with the logic too much. So let's just go like that. And we'll put this one back where it was. Okay. So does that mean we get that error? Or no, there's probably other places where it just crashes first. Let's not worry about that error right now because we know there's more work we need to do. With this anywhere, remember anywhere that has this. So that's parsing we've done. We're not going to do generation yet. Procedure, that's also generation. Type checking assignment is what we already took care of. Type checking call and type checking types. Oh, this is just getting the type name. So in here we need a param LHS node. Like so. And then there was type checking call. So I think we can get these ones. So here we use it just a little bit. So that's still right, but this here, we want the LHS node. Which is the first child, because this is a assignment now. Okay, so I think that's everything in type checking that uses that. Is that? I'm just thinking, is there anything else we need to change? I think all we care about right now, there's some more stuff we'll have to do, but right now let's just take care of that. Making sure that all of these function. Actually, no, I think we're going to need to add some more checks here when we do a call. For example, this wrong number of parameters. This needs to be modified a bit. So this is, I think I'm going to extract these so I can understand better what they mean. This is the parameter count. So this is like the amount of parameters that are actually in the procedure can take. The actual parameter count is this one. This node is the call node. And a call node, when you call a procedure, the first child is the name of the procedure, and then all the nodes after that are children. So we subtract 1 to get the actual parameter count. And expected parameter count. So maybe the expected parameter count can be like, or it's more like the min parameter count. Let's call that the max parameter count. And the min parameter count, I guess we'll loop through the parameters until we find one that has a default. So while min parameter count is less than max parameter count, and the length of this guy's children so the length of the children of that parameter is 1, i.e. it doesn't have a default. Then we add 1. So when this goes false, then we quit the loop. Well, when either of these go false, then we quit the loop. So that's the minimum parameter count, max, and actual. Okay, so now we can say if the actual is greater, or let's go less than the min. Oh, every time with the keyboard. Or the actual is greater than the max, then we have a problem, right? So this expected, instead of just putting this directly, I'm going to put, oops, I guess it's this. I'm going to put a variable. So this is the found, so that's the actual. So the expected, I'm going to do like a, I think I should be doing this a printf a lot more, maybe instead of I to A, because it's just a bit nicer to use. So we want format. Do we use slice? We do use slice. So let's see. So if the min is less than the max, so that means that there's a range that we can expect. Then we print that range, the acceptable range. Otherwise, we just print the, well, we can print the min or the max. I think they should both be the same. Okay. So we're making sure we have the right number of parameters. And now here, we only need to do this for the amount of parameters that we actually have, which we are doing. Yeah, so I think this stays the same. I don't think that needs to change. But we should have a check back here when we're going through the nodes. We should type check each node, which is an assignment node now. Type check assignment. And part of that, I'm pretty sure we'll do this. Go type check assignment. I think it's down the bottom. Oh, it's the same. Same. It's so recursive. But yes, it does this down the bottom. If it finds something new, it adds it. So we don't need to do this anymore. But we'll set it to stack before we go in. I think that will be helpful. And then we'll say, I guess we have to pass in the context. And we better all return. There. So that should do all the checks that we want, I think. That should make sure everything is okay. So now we can move on to generation, assuming that this is all working, which I doubt. GLSL, the GLSL might be easiest actually. So let's try that first. The GLSL program. So here's the param0 node. Yeah, so we need to get the param0 LHS node. And that's the one we want to use here. Also here we have the same thing. So that's param node, param LHS node. that's it. Okay. So that's all that. Then there was GLSL call. So here, we're generating the expression from the parameter node. So this is the part where it depends. So if we do have a parameter node to use, and the thing to note now is that this call also has a type node now. Optionally, it might have a type node if this call has a return. If the thing being called has a return, then there's a type node. So we have to be careful of that. But we need to check, like, can we get this parameter node? Does it actually exist? Like when we called the procedure, did we actually supply a parameter? Because we might not have if there was a default. That's the question we're asking here. So if the length of the children is less than that, I think, yeah, if the index we're using is less than the length, then we can do node.children, but we also need to check, is the child in question a type? And if it's not a type, that's good. So if we do have, if a parameter has been supplied, you know, a node exists and it's not a type, that means the parameter has been supplied. And that means we can generate the way that we were. Okay. Otherwise, we should be able to get it from this guy. This is part of the type. This will be the assignment node. So we need to get the right-hand side of this. And then that will be our expression node. So like that, basically. The second child was the right-hand side. Okay, and we know that it will have a default because of the type checking is taking care of that. Okay. So now I think we've done GLSL this, GLSL that. So now I think it's down to for x86, it's the call and the procedure, it looks like. So we'll go to procedure first. So here we're figuring out, basically we need the name of the parameter and the size. So we just need the name and the type of the parameter. So this has nothing to do with defaults. So we can go param LHS node param.children 0. Like that. I think that's it. That's the only place that it's used. Okay, that was easy. So this call, I guess, would be the tricky part. Again, we're doing size stuff. So here, so this one, did we? Oh, we just have the index. Interesting, it's that kind of loop. Yeah, here I don't think we actually needed to do that. And also here, because param LHS node is the one we want a pointf of. Like so. Where else do we use it? Okay. So this is for extern, we have this calling convention, and then for our procedures in our language, we have this other calling convention. But both of them have this generic expression with the parameter node, and this is where we need to do something similar to the GLSL call, where we do it based on this. So I think we just need like probably the same condition. I might even actually go expression node. Because this one we need a return, so I don't really want to have it inside the if. And maybe for consistency, I'll do the same thing in GLSL. So they say this is expression node. So the expression node is either that or this. And then we put the expression node in there. So let's do something similar to that. That's basically going to be that, I think. Right, that didn't exist at all before. But we don't need that anymore. And instead we put expression node. Okay, and I'm guessing that wherever the other place is, here, we do basically the same thing. Yeah, like that. Okay. Is that it? I'm sure that's not going to work. Types any string and U8 are not compatible. Well, that's interesting. Why the hell is that? That seems like a very random error. Strings 117? Oh, it's in this import call. Ah, because import is defined in here, where we manually create the AST. But now that each parameter, this should be a assignment, not just an identifier. So we need to make an assignment node, and then under that, we need to have our parameter. And we need to do the same thing here. And here. Unfortunately, here we have 3 parameters, which makes it a bit annoying. Like that. Oh, hopefully I get this right. An assignment, and now because this has 2 children, 1, 2, that's why we have to do 1. Abstract child is an identifier, and its child. Okay, I think that's right. I hate having this manual stuff here. I'm going to try and reduce that. But hopefully that solves that issue. Vertex shader name has already been declared. Okay. That's an example code. Oh, I just noticed it right here. Ah. So it's declared in this outer scope, but because this is a procedure, it shouldn't see it, right? So the node is vertex shader name. Yeah, from vertex shader name, fragment shader name. So it's from this line. Yeah, so it's this vertex shader name. And the identifier node that it's talking about is, yeah, vertex shader name compile shader. So that's, so you can see this one. And it's like, hey, you can't redefine it. But we are, yeah, we're inside a procedure. This is type checking a procedure, which gets a brand new context. So there's no identifiers in here. Then we type check the statement, which is an assignment, the procedure assignment. And as part of that, we type check the assignment, which is the parameter. And somehow it sees it. Ah, but get identifier node. Ah, it's, I did this wrong when I did this. You shouldn't be able to just see anything in the outer scopes. I don't like this name, but I don't know what name to give it. So if I pass in an identifier node, then, so yeah, this used to be in this type checking when we copied to a smaller context. It used to do all these checks to see like which ones it would copy down. So if it's a type, it could be seen below. Don't worry, this will make sense soon, hopefully. If it's a type, if it's a module, get type. If it's a module, or what was the other conditions? I think just if it's static. So get allocator, it's GLSL, or static, and again, I'm going to say, so I don't want GLSL referred to directly here. Oh, I didn't actually call it. Where was that context? Yeah, so the idea is, if we're looking directly in the identifiers, everything is visible. When we're here, if the path length equals that, then we're looking at the current procedure, so everything is visible. But if path length is less than that, effectively that means we've gone up a level. So if they're equal, then it's all good. Or if it's visible nested, so if nested context should be able to see it, then we'll also return it. So let's go identifier node, identifier node, like that. So only if it's the current context or if it's visible in a nested context, yeah. And then when we come to the module, basically we just always say it has to be nested. So it's the module identifier, like that. And program also. I mean, program only contains these things. There's no point in it containing things that are not visible nested. But let's just put this here anyway. Okay, so now that other variable should not be visible, right? Okay, so we got past that. On to the next error. Let me just close a bunch of these files because we've got so many open. Okay, so Boomstick 34, no, 31, 34. So I can't see GLS or kernels. Because that's none. Yeah, I have two minds about whether to put none in these kind of checks, but let's put it there for now and hope that it works. Hey, procedure parameters with defaults cannot be followed by parameters without defaults. We purposely put that error in there, right? Good, so we were supposed to see that. So let's make it a default. Okay, get a crash. Oh, this looks like another place. I must have missed this one. So this one, param node from type. So we need another, oh, there's also this one. These are both wrong. Did I do it here? Params type node, param node from type. Didn't need to. Okay. So I'm sure I did do it before because I remember naming it. Param LHS node from type. Oh. Children 0, and then we use that one. But not here. But we use it to get the type. Because it's actually the LHS type node. Okay, and we need to do the same down here. So I can probably copy both those lines. Like so. Okay, let's try that. Hey, it works. And we have all these default parameters, and we're using default parameters. Like if we call write, or in the right procedure, we're calling syscall, but we're not supplying these. So if we look for this in the assembly, yeah, so we can see there's still 3 zeros on the end. These are the 6 parameters. Let's get rid of a bunch of these files. So there's 1, 2, 3 of these params, and then there's 3 zeros there should be. And these are the 3 that got passed in, and the 3 zeros that got set by default parameters. Oh, I just realized I never set a timer. I hope I didn't forget too many steps. I usually have a bunch of steps I do before I start recording. Well, hopefully it's successful. We've been going for 50 minutes. Okay. I mean, honestly, that's faster than I thought. I thought we were going to come across more issues. I can't think of anywhere else off the top of my head that I wanted to have default parameters. But and these are only very simple expressions, just numbers. But that's really awesome that that works. Default struct members, I also want to do, but I think that's going to be, let's just go like that. I think that's going to be too much to do right now. So these 2 we fixed. So in the last 10 minutes or so, actually, I think I figured out this one is a bit more work. But I wonder if we can get that done. That would be quite cool. We have a bunch of little things we could do. But yeah, let's try and get this global module done. We have a bit of time. Confidence is high. Let's try it. So I want to have a new file in here. Globals.bang. And I want to replace, so remember we were looking at this before. I want to replace a lot of this stuff, all these type aliases, and let's just put that in here. So I want to replace it with bang code because it's a lot simpler. I could just do byte equals U8. That's a type alias. Okay. And then string equals a slice of bytes. Done. So much better. Vic2 is an array of 2 F32s, and Vic3, Vic4. Because they're built-in types now, I think I would like to, well, we have a rogue window. I thought things felt a bit slow. Let's close this. Yeah, these are our types. So what did I want to add? GUV. Our Vix. Cool. So they're nicely highlighted. Now link, so import proc returns a module, which right now I don't think I can do, so we'll leave that one in here actually. But I think the other 2 procedures I can do. So that's nice to cut a bunch out of there. So link is a procedure that takes one parameter which is called name and type string And it doesn't return anything, I don't think. I think that's it. See how much easier that is. Compare exchange. Oh, but we don't put equals because this is actually declaring. I think I'm going to put at none so it doesn't try and generate anything. So compare exchange returns a bool, and it takes 3 parameters: value, expected, replacement. Value is a pointer to an I32, and expected and replacement I think are just I32s. Yeah. Like so. So hopefully that replaces a whole bunch of that crappy code and it's much more concise and easier to change, right? And if we change the structure of our AST, because this is getting parsed just like everything else, it just works. The only thing that's going to be a pain in the ass still is this import procedure. Or I think there are other places where I do this, but I want to try and reduce it. I think way, way, way down the line, when we get into like compile time execution, which is like our meta programming that we might add to the language, this kind of thing might be avoided. So basically we want to compile this file and add all the identifiers to the program. So load module parsers, type check program, that's type check statements. Okay, so I think we want to, I think we want to like load, and the thing, type checking depends on program. So if program also depends on type checking, that becomes an issue. So I think I'm going to put this in main to avoid these kind of cyclic dependencies. So like, type check program does a load and then a type check. Yeah, maybe that's an easy way to do it. Yeah. And then type check one. Yeah, okay. Let's do that. It feels a bit weird to do another one, but so this is where we get the code. So let's do this, and we'll say this is the globals. Factory globals module file. So that'll be standard lib /globals.bang. And string globals data, and the name is globals. That's the module that we want to type check. Okay. Was that it? And then once we're done, we want to go through does it add? Yeah, when it does type check module, yeah, it adds the identifiers to the module. Because we want to grab the identifiers and put them onto the program, remember? So for identifier in, let's say global globals module is the program.modules globals, and for all of its identifiers, let's move them to the program. Like so, from the globals module to the program. Okay, let's see what happens. Invalid token type closing square bracket. Let me just double check our time here. We're just over an hour. So globals 2, globals 216. So it doesn't like that bracket. I guess we've never done an alias for a slice before. And I was tempted to, I think the reason might be because this is a right-hand side of an assignment, right? So it's parsing a right-hand side expression, a right-hand side primary, and right-hand side primaries are assuming that this is like indexing, you know, indexing like this or like this, but not this. And I had been thinking it'd be nice to make this consistent. So this is creating a slice of a type, but I would like it, where's an example? Like here, this is creating a slice of a variable, and we just want to slice the whole thing. I was thinking to omit that colon here as well, in which case that would be valid as a right-hand side thing. So that does change parsing a bit. Does it change? I guess it changes the grammar, right? Because we... Yeah, at the moment it could be right-hand side expression right-hand side colon right-hand side. Yeah, it gets really complex to try and describe in here. Maybe because we don't have that much time, I won't worry too much about the grammar. But if we go to parsing, primary, and we go down to the bottom somewhere, I think. Here we go, square brackets. So depending on what type of primary we're parsing, we'll give it a different type and a different value. And then for types, we do this. So this is for right-hand side. And we add a nil node. So if we have something like colon 7, we'll add a nil node for this part and then 7 for the second part. That's the idea. And if it's just a colon, then we add 2 nil nodes for the start and the end. So now we want to do it without the colon. The colon should, well, the colon can be there if you're specifying one, but if you're specifying both, there should be no colon. So we've already consumed the opening bracket. So I guess one case is if we get here and the closing bracket is what we find, then maybe I'll separate them like this, left and right. Well, that's start and end. That's what I call them, start and end. They're both null, done. Otherwise, if we come across a colon, that means we're starting with a null. And then we have a colon and then an end expression. And the other option means that we have a start, and then we might have a colon. And if we do, because we need to also cover just a single number, because it could be just indexing, it could be just doing this to get one element from it. That's also valid. So that would be this and not finding a colon. But if we do find a colon, there might be a value after and there might not be. Yeah, it's like this, I think. That means there's no value after, that means there is. Yeah, I think that's it. If we cut out whatever that was, I think that covers all of our cases. We come up against this straight away, that means we've got two empties. And it's always an index with an empty value when we're talking about this stuff, so we don't need to worry about that. Okay, I think that should parse it correctly. And I don't think it actually changes the structure at all. Procedure link must have a procedure body. Yeah. So yeah, it's not extern. Yeah, this is another place we've got none. Do we need to take this out of here? I feel a bit weird that it's in some places and not others, because we did say... No, that was just saying that it should go further down. We weren't saying that it was static. So if we say that it's not static, does that work? Invalid token type closing square bracket. (102). Okay, we could improve these error messages, because what it's saying here is that you should at least have a number. If you're going to have a colon, you're going to have something after that. I think what I want to do is, right now it basically just has some really generic error during parsing. So let's say like more descriptive parsing errors. Contextual. So it gives us some information about actual context, because it would be nicer to say like, basically you can't have just a colon, you need to do something different. So we can take that out. Let's look for this in bang code. Oh, I guess that was all of them. Any string and U8 slice are not compatible. Well, that's strange. Vendor GL16. Ah, that's this link again. Okay. So that's not to do with all the default parameter stuff, because that was working. The only thing we changed now is the slice stuff. Any string and U8 slice are not compatible. The one thing I'm kind of a bit worried about is, I think it's in type checking types. Yeah, here when we're resolving types, there's a bit of an annoying thing where, because when we, on the right hand side of an expression, we parse like this, like we just set up, but then if it's actually a type, it should get converted to being a slice or an array, and it should have type. So that's what this code does. So I'm thinking maybe because we add those nil children, it might be causing difficulty. But we were doing that before, right? What is this node? This is the index node. And if the children is 1, then it's a slice? What? Shouldn't it have 3 children? Because when we parse it, was this the parsing? Yeah. When we parse it, see, we add 1 child, which is the identifier, like, or you know, what are we indexing into? And then we add 2 children if it's a slice. If we're doing a slice operation. Yeah, if we're doing a slice operation, we add 2 children. It's this one. Or we go into here, we add 2. Or we go into here, we could potentially add just 1, but then it's an array, not a slice. Yeah, if it's a slice, we add a second one. So an array should have 2 children, and a slice should have 3. I'm going to switch these around. So I said an array should have 2, right? What happens now? So yeah, the other thing I was talking about with children, like the fact that these are the same, it could be because when it checks if 2 types are compatible, it does it recursively. So if one of them got parsed as a type directly, it will have, and it was a slice, then it will have no children. See, this is only if there was a number in there, then it becomes an array. That's for an array. So it will have no children. But if we come down here and it gets parsed this way, it gets 2 children, and then later it gets converted to a slice. So I think what we need to do is say, if we're talking about a slice, I think it's resize to 1. So I said it had no children, but it does actually get this child, the thing that it's slicing into. And this got 3. So we'll resize it back down to 1. Does that fix that? Okay. It works. He said with confidence, knowing that it would work from the beginning. Okay, that was a bit of an aside that we made this change. There is actually one other change that I want to make to the syntax of slicing. Like here's slicing with some index in it. I would actually like to go like this. Like this, and I want to use this for range-based for loops as well. Like I feel like this is more like a range operator. And it's because that's what we're saying really. We want to make a slice which is the range, and we can omit the start, or we can put 0 to there. So I like the dot dot instead of the colon. But for now it's a colon. That's the other change I want to make. Okay, interesting. So now that's like that. I kind of like that consistency. That's the same that I did with pointers. Like this is a pointer to a value. And up here somewhere I do it. Here's a pointer to, I guess that's also a pointer to a value. No, but this is declaring the type, right? This is the type. So it's a pointer to this type. And it's done the same way. You just put this pointer symbol at the start. In a lot of languages, like in C, you would put a star here, but down, where was it? Down here, you would put an ampersand, right? And in Odin, you put an arrow when it's a type, but you still put an ampersand when it's this. So, and I just went, let's have the same symbol. So it's the same syntax for both, and now the slices is also the same syntax for both. Okay. We are at an hour 17, and I'm pretty happy with what we got done. So let's leave it at that. Thanks for stopping by. Have a good one. Ciao for now.